Hi, it's great to be here. I think it's a great idea to have this venue here. When I saw the school and when you got in, I'm like, oh, this is awesome. It pushes me to tell you a secret that I haven't shared with too many people. I'm not sure why, but I think it has played an important role in our work, is that we have been interacting a lot with people that are in a school like this in Manitoba when we generated ZMAP and a vaccine against Ebola as well, where we ask how do you help and how do you stimulate creativity from your angle, making sculpture and those. And you will be surprised how much, not only common ground we found, but how much new angles on both sides we discovered. And now we have extended that to, in Quebec, to a composer of classical music. And to be here, I'm almost like feeling like home. And so I encourage anybody that is doing scientific research to think about this, to go and vice versa. Go and reach out and see how many things you have in common in terms of how you create and how you stimulate creativity. So that's one secret. To be back on Ebola, I'm here to tell you about ZMAP, which is a treatment against Ebola. And on this slide that you see up there, what the treatment is basically when we get infected by a pathogen, doesn't matter if it's a bacteria, virus, or anything, we develop our defenses, immune defenses. And part of them are antibodies that are being made. Antibodies are like small molecules, like small missiles that we throw basically at the invader. And the treatment against Ebola is based on isolating these antibodies, producing them in a test tube, and then giving these antibodies or those immune defenses to people that are infected. And Ebola, like in many pathogens, there's a race between the pathogen and the ability of the person to defend himself. So when you have somebody that goes through the disease and recovers, then it means that the body was more efficient than the virus at mounting the defenses. And unfortunately, when there is a fatal outcome from an infectious disease, it means the pathogen took over and was toxic to the host, basically, to a point where the host couldn't survive anymore. So this whole strategy is based on this, and you know it's not new. It was developed in the 70s, the mid-70s, but it had never been really used for infectious diseases. And this is what was new in the context of Ebola, is to take that approach and make it happen. And the way it works is you go get each one cells in your blood that is involved in those defenses will produce one antibody. And we can now go get this one cell and get this one cell to produce this one antibody in a test tube. That's why we call it monoclonal, so it means one. And a clone, it's not a clone like in Star Wars, it's just a clone, meaning like the cells can expand and produce this one antibody, and we can mix them, and that's the treatment. I'm spending a bit more time on this. I'll tell you why, because this is now being used for a lot of infectious diseases, including HIV, including RSV, respiratory syncytial virus, including influenza, and so on and so forth. Also for cancer and autoimmune diseases. This was, for those who are working in an environment that are not always the easiest, this was in an environment where actually the scientific community had published this last paper in 2010 saying it's not going to work. It did not work, it's not working today, and they went as far as saying it will never work. And this is a very strong statement when it's very hard to predict the future. And so in this environment where it was hard to convince people to believe into this project, there was Chu, who is in the room here, who is sharing the word, that believed into it. Not only that it will work, she believed it was going to be the best treatment ever developed against Ebola. So this treatment was advanced close to clinical usage, but had never been tested in humans for safety or efficacy. We only had animal data, which means that we could save animals from Ebola infection that could have been lethal. That is after years and years of work from test tube to mice and so on and so forth. So when the Ebola outbreak hit in West Africa and over 28,000 people got infected, there was over 11,000 people that died from this outbreak. In 3 countries, it was completely destabilizing the countries, not only the social tissue, but also the economy of those countries. We had, at that time, only animal data. But I want to show you first how a virus like Ebola, every movement you see is one person that moved and infected more. And when you see at this point, the virus will enter this location and it took off. And this was completely out of control. Ebola is not even highly transmissible compared to influenza, for example. So you can imagine that an infectious disease, how it can be damaging and can get out of control quickly. So the fact that the treatment was at least as advanced as this and being the best experimental treatment known at that point, it was used for Ken Brantley and Nancy Whiteball as the first two recipients that received the treatment on a compassionate ground. So Ken was and is a physician, was at the time in Liberia and got infected treating patient in Liberia, and Nancy was also working with him as an infectious control specialist. They both got infected, and the treatment that we had, a treatment in Sierra Leone, so the country next to Liberia, not even in the same country, was sent to them at their request in case the infection was not going to evolve the right way, and which it didn't. So when their clinical presentation became critical, the treatment was administered following a risk assessment. So it's a risk-benefit. So you look at the risk versus the benefit of taking an experimental treatment. And this was a very important moment of this outbreak. It was early August 2014, still early in the outbreak. The outbreak was already out of control, but it signaled one thing, is that experimental treatment could play a role. And 2 weeks later, WHO had a meeting very quickly, and they assembled ethicists from around the world. And their mission and their one question they had to answer is this ethical? And it took them a day of talking to be unanimous on the answer, which was yes, it was. It was ethical to consider experimental treatment and experimental vaccine in following a risk analysis. And this was a big green light of using all these vaccine and treatment in West Africa. So this has impacted even this bold move, which was also very risky, has impacted positively the following evolution of the outbreak, and actually the evaluation also of the vaccine in the field. I want to tell you as a final slide and message that this was all done and is done with the focus and the goal of helping one person, and we ended up helping a lot more than that. And I'll give you an example of why this is important, is that if we in this room, all of us help one person, we all get help today. Well, you can expand that to the planet level and the entire world population. So, I think this kind of step forward was very important and will keep to be important against infectious disease. And I encourage you to use the same approach of trying to help one person and also benefit from the help of others. That's it. Thank you so much for your time.